In this section, we take a quick look at the leading deep learning libraries. So there are 4 libraries that are the ones that everyone's aware of and that have a lot of support. Those are Caffe, Torch, Theano, and TensorFlow. In addition, there are 2 high-level APIs, TF-Learn and Keras, that are used a fair bit to call on one of those 4 libraries in the background and to build deep learning neural networks a bit more easily. So this table here is one that I created, but is based directly on a slide created by Justin Johnson in his 2016 lecture at Stanford for the CS231N course on machine vision, specifically lecture 12. And so he deserves credit for this. But it's a beautiful summary of the pros and cons of these 4 libraries. So if we look at Caffe first, we see that it can be coded up in C++ or Python. And in fact, 3 of these libraries can be called from Python, all of them except Torch, which is called from Lua. So from these, people who are using these live lessons, they're probably familiar with Python. And we've been doing everything here in Python. So that's certainly a pro for me that we can be calling TensorFlow from Python. But that's something that's also available in some of these other languages. Pre-trained models are most readily available in Caffe or Torch. So if you wanted to use a deep network that's already configured on millions of images like the ImageNet data, on a very deep network that would have taken weeks to train, and you just want to retrain, say, the top layer to your own images, Caffe can be a very good place for that. So can Torch. Now, in TensorFlow here, it says just inception, which was a particular neural network architecture that had very good results in machine vision. Now, since I created this slide, in fact, TensorFlow has developed quite a few more pre-trained models, so you can find quite a lot there as well. In terms of parallelizing your jobs over multiple CPUs or GPUs, all 4 of these libraries can do that with their data. However, if you want to be distributing your model over parallel GPUs, the best libraries for doing that are Torch or TensorFlow. And TensorFlow stands out as the best one overall for that. So another tick in the box for TensorFlow. In terms of readable source code, TensorFlow is actually a little bit tricky. There's a lot that is beautiful about TensorFlow on the surface, but that means that when you get down to the nitty-gritty, it's relatively complex. It would be difficult to be making your own kinds of changes. In Caffe and Torch, that's a bit easier. In terms of RNNs, which aren't the focus of these live lessons, but we will be focused on them in future lessons, TensorFlow is again the best here. And in terms of high-level APIs, so throughout these live lessons so far, we've been working with Keras, and Keras can call either Theano or TensorFlow in the back end. But in 2017, major releases from Keras bring it closer to working even better with TensorFlow than ever before. And so Keras and TensorFlow are closely married together. TF-Learn, which stands for TensorFlow Learn, is also closely married with TensorFlow. Keras and TF-Learn have a similar kind of syntax, but Keras is more widely used, so that's what we used in these live lessons. Now that we've covered the fundamentals of deep learning, and we've shown you with Keras how to be broadly structuring your artificial neural networks and choosing from the array of key parameters that you can choose between, it's time now to start getting into TensorFlow proper, which is a bit more involved. We have to specify things on a more granular level. But with all this behind us, we're ready to go.